Hey, welcome back to your favorite intermediate algebra class. Today our objective is to solve some systems of linear equations in three variables. Okay, in three variables. Now, if you have a three variable equation, that means it's three-dimensional. Okay, so you have each one of these is a plane. Okay, that 4x plus 2y minus z equals 1, that's a plane in and of itself. So let's say that first plane, can you see in the first picture here on the bottom left here? Is in red, the second equation's in green, the third equation is in blue. Can you see how they intersect at only that one point? Okay, if the three planes all intersect at a point, that point's x, y, z, x comma y comma z, that's their solution. So that has one solution, that's the point. Now, over here on the right-hand side, you notice that in this case, three planes intersect on a line. So all those points on the line are solutions. Any points on those lines. So x, y, z, okay, and this line keeps going in infinitely in both directions, okay? So that would be infinitely many solutions, and we're going to describe that a little further besides just saying infinitely many solutions. Now this bottom left one here, if you notice that the three planes don't intersect, all three don't intersect at a point. So this is no solution right here. This is no solution. They don't all three hit at a point. You notice here they're all parallel. All three planes are parallel. This is also no solution right here. Okay? So you have the three situations, just like when we were working with two variables. You can have one solution, infinitely many, no or no solution, okay? But they look a little differently if you were to graph those because they're planes, okay? Let's do that exact same example right here with the three variables and three equations there, okay? Here's our steps for it. And I'll go ahead and write these out as we do this problem. Okay, the first step is you want to use elimination here. I'm gonna name each of these equation 1, equation 2, equation 3. And step 1, okay, so step 1 is I'm going to use elimination. I'm going to pick two equations, pick two of the equations, and I'm going to eliminate a variable, whichever variable I choose. Okay, let me move this down here. So I'm looking and I'm like, you know what? Equation 1 and equation 3 would be really nice to use because if you notice, when I add these up, the z naturally eliminates. So I'm like, you know what? I'm going to get rid of z. So 4x minus 1x, I got 3x, 2y plus 1y right below it there, 3y equals 0. Okay, so the z's eliminate. So I pick two equations and eliminate a variable. Here, I got rid, or I eliminated, of z. Okay, so I picked equation 1 and equation 3. Now the second step is I'm going to write it down here, step 2. Now I have to use the other equation. Here, it's number 2. You notice I've already used equation 1 and equation 3. So I use the other equation and I eliminate same variable. So I have to eliminate z here. Here, it's an h. Have to eliminate z because that's what I got rid of on the first step. Okay, so I use equation 2, which is oh, excuse me, x minus 3y plus 2z equals 14. And I pick, I can use either equation 1 or equation 3. How about I just use equation 1? Now I got to get rid of z, right? But you notice right now, if I was to add the z's up, 2z minus 1z right below it is 1z, so it doesn't naturally eliminate. So I got to force it. So I need it to be a negative 2z. So I just multiply by 2, and then that'll work out for me. And then the bottom will become 8x plus 4y minus 2z equals 2. And that bottom just stays the same. Okay, so I got 9x, I got plus a 1y, those are gone, I got 16. Okay, now, so what I've done is I found the intersection of these two all three of these planes, okay, and now I'm down to two lines, okay, line A and line B, okay, so the 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 planes 1 and 3, if you're looking up at step 1, planes 1 and 3 intersect at line A, that 3x plus 3y equals 0. Lines 1 and 2, 2 and 1, intersect, planes 2 and 1, is that what I said? Planes 2 and 1 intersect at line B, that 9x plus y equals 16. Now I'm going to find the intersection of line A and line B. So if those two intersect at a point, I'll have right that exact xy point where they intersect. Okay, so step 3, okay, I use those new equations and solve. Okay, so now I'm down to two equations, two unknowns. So my equation A was 3x plus 3y equals 0. My equation B, 9x plus y equals 16. And I'm just going to continue on with elimination. So you notice let's get rid of the x's. I got 3x on the top, I got 9x down below. So I'm going to multiply this by negative 3, so I get negative 9x on the top. So I got negative 9x minus 9y equals 0. The bottom stays the same. So I got negative 8y equals 16. Divide by negative 8. Hey, I got y equals negative 2. Now, step 4, I know y equals negative 2. I substitute into either A or B here. Okay, so one of those new equations. So let's take 3x plus 3y equals 0, and let's plug in our y. So 3x minus 6 equals 0, 3x equals 6, x equals 2. All right, we're getting somewhere here. Now I know y is negative 2. X is 2. Now I substitute into 1, 2, or 3. So one of the originals that I had. One of the originals. So let me go back up to the top. Let's pick one of these originals. How about negative x plus y plus z equals negative 1? The third one. And then we'll solve for z. So negative x plus y plus z is negative 1. So negative 2 plus a negative 2, negative 4 plus z equals negative 1. Add 4. Z equals 3. Now how do you write your answer? X, comma y, comma z. So you write it as an ordered triple here. 2, negative 2, 3. That is the point where all three lines intersect. Okay. 2, negative 2, and 3. So that's the process that we're going to go through to solve these things. All right. So what would happen now if you are solving a system with infinitely many solutions? Okay. Solving a system with infinitely many solutions. Well, as you might expect, if you're going to get down and you're going to get something that is true, like 0 equals 0, and then you write infinitely many solutions, but we're going to take it a step further. So let's go through this same process here that we just did and see if we can figure this one out with infinitely many solutions. Now, step one, I'm going to take 2 and 3, and I'm going to get rid of, oh, you know what, 1 and 2. 1 and 2 will naturally eliminate my y here. So I got 3x, I got 6z equals 12. Okay, now I have to use 3. I have not used 3 yet, so I have to use it. And I can use either 1 or 2 along with it. And I'm going to use 2 because I also want to get rid of the same variable. I'm going to get rid of y. And you notice that when I use 2 here along with it, that's gone, isn't it? So I got 4x, I got 8z, so I got x's and z's, and I got 16. Okay, so here's my new equations here, a and b. Okay, now I take a and b, and I go ahead and I solve this. For x and z. Okay, let's go ahead and get rid of, let's get rid of the x's here. So let's multiply this by 4, so that's a positive 12x. I want this one to be a negative 12x. Multiply that by negative 3, and let's see what we got here. 12x plus 24z equals 48. Down below, negative 3 gives me negative 12x minus 24z equals negative 48. And you're like, oh, that's gone. That's gone. So I got 0 here, and that's gone. 0 equals 0. So right here I can say, oh, this is infinitely many solutions. Okay? So right away I know it's infinitely many solutions because this is true. So this is consistent dependent, infinitely many solutions. But the difference here is with 3 dimensions, okay, is I know it's infinitely many solutions. So they intersect at, let me go back to the picture. They intersect on a line, right? But where is this line? Okay, it could be that line. Maybe the planes intersect at a different line. So you actually take this a little further and you want to describe where this line is in terms of one of the variables. Okay, so let me go back here. So what do I mean by that? So let's be more descriptive of solution. Okay, so we're going to kind of be a little more all-American here. So what I'm going to do is I'm going to take A or B. Let me take A. 3x plus 6z equals 12, okay? And let's say I'm going to describe x, y, z, and my goal is I want to describe this thing in terms of z, okay? So why don't I solve this? Let me take either A or B. And you notice I have a z in here, right? So I could solve x in terms of z. So x is, now I'm going to say, well, x is negative 2z plus 4, comma, haven't done y yet, and then I have z. Okay, I'm trying to describe everything in terms of z. In other words, how I'm being more descriptive here is, let's say we picked our z was a 1. Then we know our x value is negative 2 times 1 plus 4, in other words, 2. So given a z, I now know my x value that's on there, and I could figure out my y value too. I just have to describe the y now in terms of z. Okay, so now I'm going to keep going here. Let me go back to one of the original equations, either 1, 2, or 3. Let me take number 1, x plus 2y plus 2z equals 4. Okay, so now I take x plus 2y plus 2z equals 4. Now, I'm trying to solve for y and have it all be in terms of z, but you notice I have an x here. So I'm going to use this x, Okay, so make this replacement. And now we're going to solve for y. Now you notice I only got y's and z's. So I can solve for that y. So negative 2z, you notice I got a plus 2z over there. So those are actually gone. 4 plus 2y equals 4. Subtract 4. Divide by 2. Guess what? Y ends up being 0. Y ends up being just 0. Okay, so here's my x comma y comma z. So I say infinitely many solutions, but I know it's of the form negative 2z plus 4, 0, and z. Okay, so again, here's an example solution. 0, and remember how I picked 1 for z? Why don't we pick another one? What if z was 2? Or we'll go 3. What if z was 3 here? Now I know if z is 3, negative 2 times 3, negative 6 plus 4, negative 2. So negative 2, 0, 3 would be a solution on this line. On this line that is the intersection of the 3 planes. Okay? All right, one more here. Let's pick a couple here, 1, 2, or 3. Let's eliminate a variable. I'm going to pick 1 and 3 because my x's naturally eliminate here. So I got negative 2y minus z equals 8. So now I have to use equation 2. And I have to get rid of x. Okay, so I'm going to pick, I could use 1 or 3, but I'm going to pick 3 here. Negative x minus 3y plus z equals 5. Okay, I have to get rid of x, so I'm going to multiply this thing by 2, so that becomes a negative 2x. And then, you know what, let me write this down below here. Well, I got room. Negative 2x minus 6y plus 2z equals 10. This one stays the same. 2x plus 2y minus 4z equals 1. Gone. Negative 4y minus 2z equals 11. Okay, now I use those two, so A and B. I'm going to use elimination on those. Let's get rid of z here. So you notice I got a negative 2z on the bottom. Let's make this a positive 2z, so I'm going to multiply by negative 2. Looks like we'll have 4y plus 2z equals negative 16. Bottom stays the same. Negative 4y minus 2z equals 11. Gone, gone. Looks like we got 0 equaled negative 5. Is that true? Of course not. That means this is no solution. So either they're all parallel and they never cross. Okay, so it's either one of these two situations on the bottom. Either they're parallel and don't cross, or maybe they intersect, but they don't all intersect at one spot. All three of those don't intersect at one spot. Okay, so no solution. All right, I hope you guys got a feel for this. We'll see you guys. Make sure you bring your questions to class. Talk to you later.